the solution actually is maybe a couple hundred kilometers up in the air. So first off, let's talk about satellites, right? So again, I think it would be nice. I don't know what Messi had planned, but I think it would be nice to have maybe like all of the questions or comments afterwards, right? I'm guessing that would be the ideal thing. So if there's any part you probably don't understand or you want to talk about more, I'm happy to do that. But I'm just going to make it as simple as possible and as straightforward. So generally, and layman terms, satellite is any object that orbits Earth, right? So they could be natural or human-made. For one, we know Earth as satellites of its own, like the moon. And we know the other planets, they also have objects that orbit them at different, polar inclinations and all of that. Like we have generally all polar objects, like all other objects apart from here, so Mercury, Venus, Jupiter, all of that. They also have, some of them also have moon of their own. Some have more than one, some have like numerous. But for Earth, we have the moon, and it's our satellite. So in the case of Nigeria, we have actually launched a couple of satellites. So let me try and see how to make it a little bit easier. So if you look at the bottom of the screen, you can see Nigeria has launched a couple of satellites. So the Nigeria EduSat-1, that was a project that was done between Federal University of Technology, Akure. I'm not sure if you're familiar with it, but it's FUTA in Akure. It's a very small satellite. It's a one-use satellite. Again, when I'm done, if you want me to explain some of these terms better, then fine. But it's a one-use satellite, and it sadly cannot do so much, but it's generally used for technology demonstration, right? So you want to do proof of concept that something works. Generally, in engineering, if you want to build something large scale, you have to start with like a POC. That's a proof of concept, so that you can figure out all of the intricacies, figure out all of the issues before you build it at scale. So there's Nigeria Sat-1, Nigeria Sat-2, and Nigeria Sat-X. Those three satellites were launched by Nigerian satellites too, but they were built by Nigerian engineers that went to UK. There's a company called SSTL. That's it's in UK. So they are a components manufacturer. They also assemble satellites. So Nigeria sent a couple of satellites to the UK to build and launch these three satellites. They are Earth observation satellites. We're going to talk about that later, but they are AO satellites. The last, so you also have NICOMSat-1. NICOMSat is like a communication satellite. So think of what you know about Starlink right now, but it's just different. I'll tell you why it's different. But NICOMSat-1 is a communication satellite. Then you have Telsat-1. So I don't know if you're also familiar that you can also use satellite for surveillance, for security apparatus and security personnel in the country, to monitor your borders and all of that. So Telsat-1 is also being managed by another entity called DSA. We'll also talk about that later. But we figured out what satellites are to a very large extent. And so we also now know there are different orbits. So the best way that I've been able to figure out to describe what orbits are, that's if you don't already know what they are, is think of different cars that are moving on the road. And think of each of them going to their respective houses or their respective offices and all of that. So orbits are like just specific points in space. So that's beyond the Kármán line. Kármán line is the imaginary line that separates your Earth from outer space. So once you pass 1 meter above Kármán line, that means you're in space. So that's like the main difference. So the orbit is now any point that has been assigned to a particular object. This object will now be what? A satellite, right? In space. But there are different orbits, meaning there are different locations for satellites to stay. And these locations are also born out of need and necessity, right? So it's you would design your object, sorry, again, object satellite, you would design your object based on what the needs are and exactly the kind of configuration you're looking for. So there are lots of orbits, but the major ones are this LEO, MEO, and GEO. LEO is low Earth orbit. It's the lowest. So you also have, so technically, right, you have very low Earth orbits. But I think for the purpose of this call, let's just start from LEO. So that's like low Earth orbit. And it's usually like 200 to 2,000 kilometers. So that's like the line that divides it, right? So you generally sometimes have satellite that orbits there. They're used for EO, that's Earth observation. Some of them are also used for internet connectivity, like Starlink, right? So there's also, like I mentioned, there's very low Earth orbit, but we probably will not be talking about that right now. Then there's MEO, that's the medium Earth orbit. And that is around 2,000 to 35,786 kilometers. And they're basically used for GPS. So that's where you have navigation and positioning. So the US version of navigation system is called GPS, which is like the most, I'm sure everybody knows GPS, right? And then there's the European version, EU version of it is called Galileo, named after one of their, is it a god or something? Then you also have for several other regions. So the Chinese version is called Beidou system, BDS, and like that. And then for Geo is above 35,786. So generally, if you want to think about Geo, think of it as, if you look at a satellite that is in Geo from Earth, they look stationary. Why? Because they are meant to orbit the Earth at the same speed, right? So that makes them look stationary when you're looking at them, right? So it looks like they don't move because they move at the same pace as Earth. And this is really important when you're talking about your satellite dish. You know why your satellite dish is always in one position? It's usually just tilted towards southeast, right? Okay, let me not go to detail there. But the point is, your satellite dish, which you use to connect with like satellite in orbit, they just focus on one particular part. If the satellite is not in geo, meaning if the satellite is not orbiting at the same space as Earth, then that would mean that for you to be able to get access to whatever services you want to use with DSTV, you probably have to be moving the dish every single time. But then just because the satellite is in geo and it's stationary, then that is why it's easier for you to just put your dish and make it face one particular position, and it stays that way, and they can get access to whatever information and video, voice, and all of that from space. So there are a lot of issues, right? And these issues are not just a Nigerian issue; they are global issues. I'm sure you probably would have heard of SDG goals. These are like the sustainable development goals. So this, just to say, these are not Nigerian issues. These are issues that are global, right? But what are some of the issues that Nigeria can actually solve using satellite? So I just noted 6 of them here, so we can just walk through them very quickly. So the first one, there might be power issues, right? There's power issues in Nigeria. We all know that. The next one, you can also think of water and flooding issues. So monitoring like flooding issues and also providing early warning systems to curb the issues of flooding. There's also food security. 25% of our food is insecure in Nigeria. Then there's also healthcare access. We need more healthcare practitioners, but then we can also make that work with just e-health. So one of the issues is you can say, okay, there's one doctor per 6,000 people, which is very terrible, right? When you think about it. Then there's also the issue of digital connectivity, and then there's security and conflict. So let's just take them one after the other. So the power crisis. And so on the right, you have like the solution or possible solutions. And on the left, you have like definition of the problem, sort of. So the first of, just to contextualize it, so Nigeria generates around 4,000 megawatts for 200 million plus people. Now South Africa, they have a fraction, like a third of our population, right? 60 million people, and they generate what, 50,000 megawatts. So you can already sense the issue now. So many people we have in Nigeria, and then there's like so little to actually cater for them. So the result is, for most part, you have 16 plus hours of darkness daily in many states. It's usually more terrible when you go to like rural areas. Even in urban areas, it's terrible. So now think of what that would look like in like very rural areas or like even peri-urban areas. So what is relatable to most of us on this call? So we have that generator noise that is keeping you awake before exams. And on the right, there are some solutions that, that satellite can actually help profile. So one of them is like mapping solar resources. So basically, satellites can actually help. By satellite here, we're talking about Earth observation satellites. They can help map exactly where solar energy is the strongest, meaning which part of the country gets the most sun in terms of frequency and in terms of intensity. So frequency means like how many hours of sunlight do they have in different parts of the country. That's frequency. And then intensity, like how strong, like how intense it was. Do you understand? So those two things, you can use EO satellite to map that. So once you map it, then you'll be able to now optimize panel placement for LGS. So you know the specific places to actually to have the most viable options in terms of like, okay, this particular area, it gets the most sunlight in a day. And out of these particular areas that now have the most sunlight in a day, these particular areas within them now have the most intense sunlight. So you'll be able to now use that to optimize your panel placement. Another one is grid monitoring. So you can actually now use real-time satellite imagery to detect transmission failures, rather than doing it manually and having people to drive all over the country or like all over the states or whatever, looking for where the issues are and all of that. You can just take different screenshots. By screenshot, I mean screenshot that will be taken by EU satellite, clean it up, and then you can be able to visibly say, these are where the issues are. And also the fact that you'll be able to do that, there's something called revisit time. So you'll be able to look at the same spot multiple times. So you can now see what the changes have been a couple of days or over a couple of months or even over a couple of years. So there's also something called space-based solar power. This is currently just fairly argumentative, right? Because it's a future tech, like I mentioned here. So the plan here is like there's just lots of sunlight that is wasting away, not wasting away in the fact that it can be used for a lot of stuff on Earth. But just because something is meaningful does not mean it's economically viable. And until something is economically viable, that's when it turns to a business. So currently, you're going to spend way more to actually convert. So there are a couple of issues here. You're going to be spending way more to actually convert the sunlight from space to usable models for Earth. One. Number two, we also don't have panels that are strong enough currently to be able to absorb the UV light from space and then convert it to what we want. And then thirdly, what you would actually spend to transmit that power from space, and then when you're transmitting it, you have to also be sure that you're not losing so much of that power that you're transmitting till it gets to it. That's also not available right now. So again, it's future tech, so it's plausible, but currently it's not in circulation yet, and I'm not sure it's going to be in the next decade, right? But something that once we have like all of those techs figured out, it also becomes another viable option. So instead of waiting for sunlight on Earth, you can just get that, beam that directly from space and use it for whatever applications you want to use it for. And that would also contribute to greener economy, right? Or green economy as it's fondly called now. So a real life example is this particular agency. They're using satellite data to plan solar mini grids across West Africa right now. So that's just an idea of what that would look like. All of these are doable with just the right infrastructure, meaning you have a satellite of your own, or you sort of like just buy the data. So by buying data, you buy like imagery from commercial companies that sell this kind of images that they're looking for. And then you have people, engineers or technicians that can process the images for you, and then you use that. So water crisis and flooding. If we all stay, I'm guessing we all stay in Lagos, whether just by the virtue of schooling in Lagos or like maybe we're actually from Lagos. But you would know whenever it starts raining, the rainy season is like a very terrible time for several areas in Lagos, especially on the island, for obvious reasons, and also for obvious reasons. Let me just leave it at that. So the pain, 30 million plus Nigerians lack access to safe drinking water. And then every raining season in Lagos, there's flooding everywhere. There are entire neighborhoods in Lagos that get swallowed up. We've seen pictures, I've seen some personally. And there are some areas that whenever it starts raining, they leave their cars elsewhere and they use canoe to go between streets. It's that terrible in some places, and I'm sure some of us can also relate to that. So what is one relatable thing that I can draw here? It's okay, you're driving from Lasso and you're getting stuck because maybe the Ojo road is underwater or something like that. So what are the solutions that we can get from the satellite? Practical solutions. So there are radar satellites. These are also a type of Earth observation satellite that can monitor river levels. So they can tell you what the level of the river is like. Again, you need to understand, like, for most part, when we say data from EU satellites, they are mostly, depending on what kind of satellite, mostly they are in form of images that you need to clean up. And these images, you get them at different revisit time. So again, different satellites would have different abilities or capabilities, meaning you have some satellites that you can revisit. So revisit time means the number of time you can revisit the same spot. So meaning you have to do a complete 360 and come back to the starting position. That's the revisit time. Some satellites have like proper revisit time, like a couple of hours, where some other satellites, they are like 3 days, 5 days, 7 days, like even and more than that. So you can now take images from different days and then use that to calculate, okay, this is what the river levels would look like. And then you also now figure out what the rainfall pattern is. Okay, this is when it rains in this particular region, and then when it rains, this is where the river level gets to. So when you know all of that and you know how long it rains for, right? So it rains for 5 hours, and when it rains for 5 hours, certain areas become flooded. The rivers become flooded, the canals become flooded. So you can use that to now do a predictive model, or predictive model. You can train LLM languages, and you can just use predictive models to now predict floods hours in advance of when it's actually going to happen. So another one is you can also do underground water mapping. So there's a particular satellite from European Space Agency that can map soil moisture, meaning the content of the water content in soil, right? So they can now locate groundwater aquifers for you, for boreholes and all of that. So they can locate water tables. You know how if you're drilling, you then get like that, like when you're drilling and you're taking samples of the soil for analysis, you get different layers of the soil, and then you get like the water bed and then all of that. So you would be able to do that without actually intruding on the land using the satellite. So the satellite can penetrate deep into the ground and give you the analysis. Okay, this is where you have your topsoil, and after the topsoil, you have your loamy soil or whatever, and then like that, and give you the analysis of all and everything that is happening below the ground. The last one would also be pipeline leak detection. So this would be for where there are like water systems that flows directly into people's homes. I don't know how many of that we still have in Lagos, but I know in some states they still have pipe-borne water that is provided for by the government. So they get water directly into their homes. So you can use synthetic aperture radar satellites. Again, if you want me to explain any of these terms better, you can just let me know after the presentation. So they can use SAR data satellites, again, synthetic aperture radar satellites, to detect ground subsidence from water bursts. So meaning if a particular pipe that is transporting water from let's say point A to point B before it gets to your home gets damaged, obviously that will stop the flow of water to your house. But then in terms of now having to do that manually by having technicians go and map the entire length again to see where the issues are, they can actually do that using satellite. So a real life example of how this is actually been done. Again, we actually even have examples of Nigeria. It's like the Nigeria Hydrological Service Agency, NISA. They're using satellite data, EU satellite data, to issue flood alerts. So food security, the pain is Nigeria imports over 2 trillion in food annually. Yet we have millions and millions of hectares, 79 million hectares of arable land, and which is one of the largest in Africa. With everything that we have, we should not have some of these problems. But then again, we do have them. So now farmers rely, again, by farmers, we mean farmers in majorly the rural areas, and smallholder farmers, obviously, they rely on guesswork, or they rely on what has been passed down to them by their forefathers in terms of when to plant, how to plant, when to water, how to water, when to apply fertilizers for those that are now in tune to applying fertilizer and all of that. They sometimes are guesswork. And the fact that global warming and all of that, like the pattern is changing a bit. The rainy season is not as lengthy as it used to be. The dry season is lengthier and all of that. It makes it harder for them to predict, especially if you're relying on experience or passed down data from people that have also done it. So that is another issue. And what is relatable? So the family food bill keeps rising. Every single time you go to the market, you go the next time, and then everything is like, I don't know, 1.5 times the initial price, or 2 times or more than that. So what are practical solutions that satellites can offer? One of them would be precision agriculture. So multispectral satellites. Multispectral here means like multiple bands. You know how our eyes can only see certain bands, a certain spectrum of light, and not all of them. Like we can't see UV light with our naked eye and all of that. There's some satellite that can see multiple bands. Like Sentinel-2 satellite, it's an European Union satellite, EU satellite. So this particular satellite can actually detect crop belt, which crop is growing. So it takes pictures and also all other parameters that is needed. Once you find out by refining it, like using all of these available tools, you'll be able to detect the crop health. Are the crops growing properly or not? So how do you detect it? For example, you already have a trained model on how healthy crops look like, right? And then you train that model to say, depending on different parameters, this is what an healthy crop would look like. And then once you train the model, you can now apply that trained model to a new data set to say, okay, now figure out which of these data, which parts in this data have good crop and bad crops. So it will be able to do that for you in no time. And then you can use that it's going to have pinpoint accuracy. And then depending on how good you've been able to train the model, so that you don't have false positives and all of that. So once you're able to do that, you can now take that to the market. By market, I mean take that to the farm and figure out what to do to the unhealthy crop. You can also detect like drought set when like there hasn't been rain for a long time and you want to figure out when to do irrigation. You can also use that. And then you can also figure out soil quality per field. So what's the quality of the soil in this particular area? So you can also do that. Yield prediction. This is where you predict how much output you're going to get from planting a certain kind of crop in a particular region. So AI, again, you would have to train an AI model or an ML model plus satellite imagery. So you have the satellite image, you have to now train an AI model for it to be able to use a particular parameter that you've designed or that you've defined to now say, it's more like a go, no go kind of situation. So you train it to say, this is what a good crop or a good soil should look like. You train that model on all of the parameters, and then you use that to the images to now figure out which of the parts, which of the soil or which of the crop on this particular image conforms to the defined parameters or the defined set guideline of this trained model. So for those ones that are good, it will mark them good. By mark, I'm just trying to oversimplify, but that's just basically what happens. So mark them good, and the ones that are bad, you get like a bad feedback. So you can use that to now predict harvest output months in advance. So you actually be able to know, okay, exactly, this is to a very high level of certainty that, okay, this is how much output we're looking for in this particular region. And you can now scale that up to like the entire country to say, in 2026, we are looking forward to X amount of rice that is going to be cultivated in Nigeria. And you can do that to a very high level of certainty so that you would be able to now stabilize food prices. So if you know how much yield you're expecting, it will not be that this month or like a couple of months, then the yield is going to go down and then the prices, skyrocket. You'll be able to stabilize it because you already know what you're expecting at different time. And then the last one is illegal deforestation detection. So you can also use satellites to track forest clearing. Again, similar way of doing it. Images, right? And then revisit them. So if you have those two things locked in your mind, you can now figure out, okay, if I have a picture of a particular place in 5 years ago and have another picture 3 days ago, I can detect what is different between the two pictures. You understand? So if I detect what is different, I can figure out, okay, maybe like a certain quadrant of the image has been cleared. So you can use that to now give that to the appropriate authorities that are in charge of limiting deforestation, and they can take that up. So a real life example would be Zenvos. It's a Nigerian agritech startup that is using NDVI data to advise farmers on when to on when to plant, what to plant on different type of soil terrain, how much to plant, when irrigation is needed, and all of that. So another one is digital divide. 64% of Nigeria is still offline. And the data is skewed a little bit because if you move from the urban region to peri-urban region and to like to rural area, you figure out like there's a digital divide, and then there's a secondary digital divide, meaning majority of the people that are not online right now are people that are in peri-urban to like rural areas, right? So only 36% of Nigerians have internet, of Nigeria has internet penetration. So in rural areas, like I was trying to explain earlier, rural areas in Yobe, in Zamfara, or even in like the southeast there, it's way below that. So you have around 7 to 10%. So no internet means you cannot do e-learning. You can also not do fintech. So no digital economy, no e-health, nothing of that. So what's relatable? I've personally done this before. You know, when you're trying to browse and you have to change your SIM card, use like Glow, change to MTN, change to, I don't know, which other network is there? All of them. And then you still get like similar results. It's terrible when that happens. So that is like something that is relatable, even to people in the urban area. So now, like now, dial that back like 1,000 times. That's what it feels like in rural areas where they probably are operating on edge, or in most cases 3G that is operated by Wi-Fi stuff. So what are some practical solutions? Starlink is a very good example. So Starlink is already in Nigeria. The fun fact, Nigeria was the first market that Starlink was able to be licensed in Africa. Sort of we're like the test bed in Africa. More like we are the largest market for them. So if they were able to figure out how to work in Nigeria, they will be able to do that elsewhere. So they came to Nigeria first. It was during the time of the then minister, Dr. Isa Pantami. I'm sure you guys are familiar with him. So, and since then, it has been an upward curve for Starlink. A lot more people now know about it, use it. A lot of people are discarding their terrestrial ISPs, like MTN and the likes. So, another one is also African constellation. So, there are also African companies or African agencies that also have communication satellites. But you know the other time that I was talking about orbits, that I was trying to tell you the different orbits that we have. So Starlink is in the low Earth orbit. So that means if you have a clear night sky, you can actually see a train of satellites. Starlink satellite on a clear night. You can see it will look like multiple beams of light on like a straight line, right, or a staggered line. You can look it up online. It's very cool if you're able to see it. But that is because it is the closest path to the Earth. That is why it's visible, right? But for all these other African constellations, so there is a company in Nigeria called Nicomsat. I don't know if you guys are familiar with it. So they do communication. They have a communication satellite. It's called Nicomsat 1R. It was built for them by China. So they're still commercializing it. The company is in Abuja. It's a government agency, and they also use that for connectivity. So think of what Starlink is doing again, but then just the different, like the physics is different, right? In terms of, so let's just say the physics is different. If you want to talk more about it, it's fine, but the physics is different, but just think of it like the similar stuff, right? There's Nicomsat in Nigeria, like I mentioned. In Angola, there is GGPen. They also have a communication satellite. It's called ANGOSAT 2. In Egypt, the government has what is called the Tiba-1. That's the name of the satellite. It's one of the biggest in Africa. And then apart from the government that is operating the Tiba-1, there is also a commercial company. It's actually a publicly listed company, a commercial company called Nilesat. They also have a couple of satellites that they operate. If you go to Algeria is in North Africa, they also have a communication satellite called Alcomsat 1, Algeria Communication Satellite 1. It was also built for them by China. So a couple of these countries also have, like the ones I've listed, they have communication satellite that they're commercializing. And depending on the footprint, they are able to provide services to like the different regions that are covered by their footprint. So a real life example, like I mentioned, is Starlink, right? And with that, there are a lot of now NGOs and even government that is using Starlink to provide connectivity, e-health, and all of that for rural areas in the country. So security, so eyes in the sky and not just on the ground. So the pain is like the everyday news. Boko Haram, there's banditry, there's farmer elder clashes, there's oil theft in the Niger Delta region, there's illegal logging in Southwest and pretty much everywhere else. And the Nigeria security challenges span like 23,000 kilometers. But you cannot put soldiers everywhere, right? So that means ground surveillance as blind spots. Relatable thing is you cannot put campus security, or I don't know, are they sheriffs, or I can't remember what they are called now. You can't put security to monitor every hostel or every car park in the school. So if you can't do that for a school, you can now scale that up a couple of magnitudes, right? To see what that would look like in terms of an entire country. So you can't put people everywhere. That would mean blind spots in a couple of places. And those blind spots are the hideouts of all of these terrible people. But then how can satellites help? So there's SAR surveillance. So SAR is synthetic aperture radar satellite. So they can see through the clouds at night. So maybe I should just take a minute and explain something here so it's easier for you to understand. So like I was mentioning the other time, there are different type of EO satellites. So a SAR satellite has light beam of its own, which means that it can penetrate through clouds and it can also see at night. Okay, so it's more like you have a camera on your phone, right? Imagine trying to take a picture in the night when everywhere is dark without a flashlight, right? Right. So you understand what happens. So that's what happens to some satellites. So optical satellite is an example of that. Optical satellites can see during the day. So meaning if you also want to take it, so an example would be to liken it to make it relatable. If you want to take a picture with your phone during the day, like now, you can do that without flashlight and it will work. You can see everything and all that. But if you now go to like, when like at night or like early morning when everywhere is dark without flashlight. So that is exactly what would happen if you're also using an optical satellite to do that. But that is the difference. That is the difference that SAR satellites would give you. They have their own light beam on the satellites, and that light beam can now penetrate to the ground, and they get reflected back to them. So they can use that to now see through the clouds. So if there's like cloud cover everywhere, you probably will not be able to see very well. But with this particular satellite, you can do that. So you can see through the clouds and you can also see at night, which means you can monitor conflict zones, pipelines, you can monitor your border every single time, like 24/7, right? So there are no blind spots with SAR satellites because you can pretty much have the data anytime. Oil spill and theft detection, Niger Delta side, precisely. There's optical, like I mentioned. I just discussed what optical means. But then with optical, you can't see in the night. What you get is what you get when you're trying to take a picture at night without a flashlight. So they can help you detect illegal bunkering and pipeline breaches in Niger Delta area, and then conflict early warning. So you can also now track movement patterns. I'm sure you should be able to visualize what tracking movement patterns would look like. So you have different images at different revisit times, right? So you know what this particular region looked like 10 days ago or a month ago or a year ago. So that's how you can be able to define what movement pattern looks like. And you can now use that to flag any unusual activity where you're seeing a lot of people going into the particular region or a lot of people moving away from a particular region. So an example would be the Nigerian DSS and the military that used Nigeria SAT-2 and SAT-X. And the DivSat-1. The DivSat-1 is used by a major agency in Nigeria called the DSA, Defense Space Administration. They use the imagery for surveillance. So away from all of that, what exactly is Nigeria doing? Actually, I have that question. Like, what is Nigeria doing in space? So Nigeria have three main agencies that is in charge of the space program. So we have Nigerian. So this is the NASA. NASA is called the National Space Research and Development Agency, NASA. It's the civilian arm of Nigeria space program. and it's the de facto space agency. It was established in 1999. Then Obasanjo was the president of the country. And then in the middle, you have NICOMSAT. I was trying to explain NICOMSAT before. They are the one commercializing our communication satellite. They handle our communication satellite. And then you have the Defense Space Administration. They are in charge of defense apparatus and all of that, trying to, so anything defense related, it would be covered. It should be covered by DSA. And that also means that you would hear little to nothing about what they do. And it's designed that way because it's pretty much everything falls under, the red line of defense. So you probably will not be hearing too much about them or even about the activities and all of that. They are also in Abuja. Three of them are housed in Abuja. So NASA also, like I mentioned earlier, that NASA has a couple of satellites, like 6 or 7 of them. NASA is also planning to launch 4 new satellites. So they're trying to launch 3 optical satellites to make a small constellation, right? Constellation is more than 1. So generally 2 technically means constellation, but then they are trying to launch 3 to have a constellation. So, and then 1 synthetic aperture radar satellite. So they're going to use all of these satellites to boost security, basically using SAR for that, agriculture using optical, urban and flood mapping using SAR and optical, and all of that. So, like I mentioned, the first satellite, NICOMSAT, that is the communication satellite, it was built and launched by China, but then it was financed through a loan that Nigeria as a government, Nigeria as a country, the Nigerian government got from Chinese bank. So we serviced the loan for 7 years to buy that satellite. But Nigeria is now trying to move away from servicing another loan to get another satellite, because the satellite now is going to be deorbited by 2028. So they're trying to now shift towards public-private partnership, trying to bring in investors that is going to actually invest in the project and also offset some of the large investments that would be needed to build another satellite. So the last picture on the right, the bottom right, is was just trying to explain what I just mentioned now. We have relied on Chinese financial models for our satellite, but we're trying to move away from that. So then you can also want to ask, okay, how much exactly is Nigeria allocating to the space program? How much are we spending on space program? Again, one key thing you need to just note here is there's a difference between allocation and disbursement. So in financing terms, the government would come out at the beginning of every year, of every fiscal year, sorry, to say this is how much we're going to be spending on all of these items. That is allocation, right? And then at the end of the year or in the middle of the year, the budget office for each country is supposed to come out and say, okay, the government said they're going to be spending X amount, but in terms of actual disbursement, they're able to disburse Y amount to everyone, right? So you'll be able to track, okay, the government said they were going to give an agency, for example, Nigerian space program. They're going to, let's say in 2025, they were expected to receive $61 million, right? But in actuality, we know that last year, the government did not, the government did not allocate up to 30% to all of the agencies, meaning they have to bring forward their budget to the next year, which is this year. So that is a way to just understand how the money flows from the government to the agencies, and then you can use that to now track what the agencies are doing in return, and then you can be able to now say if there's something dubious going on in terms of maybe pocketing allocations and all of that. So, like I mentioned earlier, the Nigerian space program is being handled by 3 agencies, and these 3 agencies get a budget line from the government. So on the right, you see the breakdown of the allocation to the 3 agencies. NICOMSAT, DSA, and NASA. for obvious reasons, NASA has the highest allocation, right? And then you can see the allocation to the other guys too. 61% to NASA, 29 to DSA, and then 10% to NICOMSAT. So, and that's just to reiterate some of the things that we've been able to do. Again, 1999 was when NASA was formed. 2003 was the first satellite called Nigeria Sat-1. So the next one was 2007. It was when we launched the first satellite, communication satellite, NICOMSAT-1, but that failed in orbit. So that takes us to 2011 when the replacement satellite was launched. So the replacement satellite, you can now want to ask, okay, who paid for it? Like, if you're launching something that costs north of $200 million and it fails, what happens? So there is the same way you do insurance for your car, for your house, and you do life assurance, you also do that for large scale projects. So meaning when something happens, depending on what the terms of the agreement states, when something happens pre-orbiting, during orbiting, and post-orbiting. So pre-orbiting means when you are building it and all of that, when you are transporting the satellite itself to where it's going to be launched, right? That's pre-orbiting before it gets to the orbit. The insurance can't cover that. So if there's any issue on that, the insurance covers it, and then you get a new one. Orbiting, when it's in orbit, it's supposed to have, so each satellite, just like everything else, they have like expected deorbiting date. Like so generally when you're launching, you depending on like the sorry, okay, let me try and make this a little bit. So when you launch a satellite, there's like an expected time when the satellite would deorbit, meaning when it will expire, right? So if anything happens between that time, so meaning let's say your satellite is supposed to orbit for 5 years, and in the second year something happens, as part of your contract, if that is embedded in it, then that would mean you get a replacement satellite that is going to be paid for by the insurance company. And then in 2023, Starlink, launched Nigeria. And again, like I mentioned earlier, it was the first market entry for Starlink. And then in 2026, Nigeria is trying to launch a couple of satellites now. So NASA is trying to launch 4 satellites. Like I mentioned, 3 optical satellites and 1 synthetic aperture radar satellite that is expected to boost different sectoral applications, agriculture, disaster monitoring and preparedness, communication. So, and then NICOMSAT, the agency in charge of communication activities, is also trying to launch a replacement satellite for their aging satellite that is going to deorbit in 2028. Okay, one last satellite. So again, you probably would be wondering, okay, what are the opportunities? Like, where can I fit in here? Or what exactly can I do? Or do we all have to be rocket engineers and all of that? So the short answer is no. There are loads and loads of opportunities. So think of it as the way you have any other industry. Apart from the primary operators that will be the engineers, and an ecosystem can only grow when it has like every other moving part. So you would need the lawyers, you would need the analysts, you would need like pretty much everything else, apart from the primary operators who would be like the engineers and all of that. So generally you would need satellite engineers. So if you're looking to pick up a course, if you're doing anything, like if you're doing maybe electronic engineering, I don't know what it's called in LASU, but something along that line. If you're doing something like that, if you're doing mechanical engineering, if you're doing meteorological engineering, if you're doing mining engineering, I don't know if you have that. If you're doing engineering and you have an engineering background, you could decide to pursue a second degree in maybe aeronautical engineering or aerospace engineering and all of that. You probably would be looking outside of the country to do that, where you would be able to get access to funding, right? So it's easier for you in terms of the financial application. But that is like one of the pathways if what you're looking for to doing is like a satellite engineer. So you can either design, you can build it, and you can assemble it, or you can actually operate the satellite. Right? Those are like different kind of engineering techniques, engineering terms, and engineering processes. So you can do that if you want to stay in Nigeria. There's NASDAQ, there's NICOMSAT, there's DSA. There are lots of other opportunities again that are abound outside of Nigeria. So if you want to pick that up, that is the primary pathway. So it doesn't only have to be satellite, right? It could also be any other infrastructure that would be needed in the entire value chain of the space ecosystem, right? So there's also remote sensing analyst. So I was trying to explain the other time about all those images, how they are in their raw form, and how they have to be processed and processed to get the final information you're looking for. And training AI algorithms, training machine learning algorithms, training several kind of algorithms, just so you're able to get the best out of your images or your data that you're able to get from the satellite. There are analysts that are able to do that. So if that is what you're looking forward to doing, here again, there are lots of opportunities. And you might also be wondering, okay, how do I start with this? Again, there are lots of free available opportunities. There are opportunities that are currently being carried out by the European Space Agency that are free. So you could just sign up and you start learning. If you have prior opportunities coding, maybe if you have opportunities like writing Python or I don't know, JavaScript, obviously you would have to know how to do data wrangling. So maybe like R or SQL. So like basic coding skills, they are a plus. But I'm not saying you can't do it if you don't have all of that. It just means that you would have to learn, all of those things that you would also need to be able to do it. But if that's something that looks like something you would be interested in, then we can also look into. You can also look into that. Again, there are lots of opportunities, so you only need to do just simple random search of what you're looking for, and then you get options, and then you see how you can move, and then you see the possible pathways from the option. So there are also like GIS experts and geospatial experts. You can also be part of people that would map Nigeria's resources, again, using EO satellites majorly. Every ministry needs this skill. So the point is, you need to look at space as a tool for sustainable development in its entirety, right? So if you look at it from that front, you'll be able to figure out that it's not just about being an engineer and then building. No, you can literally fit in anywhere, because everybody would need to do things optimally, and space gives you that optimal and that precision that you don't get with other similar techniques that are on the ground, right? So for this GIS, even for the remote sensing analysts, like agencies need them, ministries need them. So that means you would be able to land a nice gig if you're able to learn it well. And again, I don't know what level you guys are, but again, if you're looking through any routes of possibly educational pathways of funding opportunities and all of that, I would just like to admonish you to ensure you finish with good grades. I don't mean first class, right? Of course, first class is super nice, but I mean good grades. So 2-1 at the very least. So you give yourself an edge. I'm not saying people without 2-1s or people with lower grades than 2-1 have not gotten it, but I'm saying it's easier, right? When you don't have to worry about that because you have it. So if you can still do something about it, please do. If you are already on the right path, please just ensure that you're able to finish well. so that you finish well with the right grade, then you have all of these opportunities and you can decide what you want to do rather than limiting yourself to some opportunities because you don't have some other stuff. So there's also like if you're a developer, there are space app developers. So they build apps with satellite data APIs. So you can infuse or embed your data APIs on different. So like your maps, like your forecasting map, for example, you can just embed um, your trained algorithm in terms of forecasting for rainfall or forecasting for flooding. You build that into an API. So you would also need like somebody that can develop a mobile apps or web app for this. Again, this doesn't really have to be, you don't have to go learn anything about space. You just need to be able to develop apps, right? The only thing is that to build the app now, you just need to understand what the process, what the product is about. Right. So again, this is just to show like it's not just satellite engineers that are needed here. Then space policy and business, like me, right? So there are loads of opportunities here. There are like we need the industry needs more lawyers, VC firms that are able to understand what the space ecosystem looks like and what the opportunities are, where the gaps are, where they can fit in, where they are best suited to bring their products and services to, and all of that. So we need regulators. By we, I mean like the industry needs regulators. The industry needs like people that understand the funding landscape and how all of that works. We also need diplomacy, people that can handle diplomacy. So we also need all of that away from like technical personnel. And last but not least, propulsion and launch tech. So there's also people building and working on launch capabilities, rockets that takes your satellites to different orbits. So someone has to build it, right? If we're saying, oh, we want Nigeria to have its own launch capabilities, then somebody would have to build that dream. If everybody is just waiting for somebody else to build the dream, then the dream would probably not be realized. So it takes just one person, it takes just one club, it takes a couple of people just to figure out what needs to be done and actually take the initiative to do it. So thank you very much. That's the last slide I have. So Messi, over to you.
All right. So thank you so much for that one, Mr. Mustafa. That was a very, 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 very insightful session. So yes, can we have the rounds of applause rolling? Thank you guys so much. So once again, I say thank you to Mr. Mustafa for that amazing session. I like how you broke it down in the most simplest of ways, right? Like you said, there was no too much technical jargon, right? But in a way that it was very nice, very relatable in a way. I like how I was saying the LASU campus, LASU security, transporting yourself from Lagos to LASU. So it really shows how much you basically prepared to talk to the Space Club's LASU student. And I really want to say thank you for that one. So a round of applause for our speaker for today's session, guys, because that was really, really insightful for me. Because it's now clear that space is not just a distant or abstract tool. Like you said, we should see space as a tool for sustainable development. And that's one thing that's going to stick with me from this webinar, right? That we should see space as a tool for sustainable development. And that is what I want to admonish each and every one of us to see space as, right? And how space is deeply woven into our lives, our system, and even the future we are trying to build as a country. And I'm sure many of us are leaving this session not just informed, but thinking differently about what space is, how we can use space, and even how Nigeria is involved in the space system, right? So, very quickly, we are moving into the question and answer segment. Do you have any question for our speaker or something not clear to you? Or are you just talking out of curiosity? Please, you can raise up your hand, drop your questions in the chat box, or you can unmute your mic and speak, right? So above us, for us, how satellite can help Nigerians, how satellite can help solve Nigerian problems, right? That's come to an end, but we are currently in the question and answer segment. So do you have any questions? You can raise up your hand or type them in the chat box. All right, I think Daniel or just already typed something in the chat box, and he said, um, how do we discover these European opportunities? Can you please send the link? I think, yes, Mr. Mustafa talked about European opportunities, and now he's asking, how do we discover these European opportunities? So, Mr. Mustafa, you have the floor to answer that particular question.
All right. Sorry. Daniel and anyone else that is looking into this. So there are multiple opportunities. It's more about being specific, like what exactly are you looking for? So if you can tell me what you're looking for, then I might be able to direct you better. So the reason why I'm saying this is, so on EU, right? The European Union and the European Space Agency, they have different projects that are even being done in Africa that you can be a part of. It's free of charge. You can start learning from there. That's it. And then if you go into satellite navigation and positioning, that's a different kind of conversation. So I just want to know what kind of opportunities that do you mean? Or do you mean pathways to probably go to like do like a second degree and stuff like that? So I just need to be clear on what you're looking for.
All right, so Daniel, if you're on the call, you can unmute your mic and speak, or you can proceed to chat in the chat box. He was asking for specificity. What exactly are you looking for in this European opportunities? So I don't know if you're typing or if you want to raise your hand and speak, but I okay. So he said any European opportunity that deals with space tech that I can start today. Any European opportunities that deals with space tech that he can start today.
That sounds like okay. So I'm going to type something for you now in the chat box so you can. So this is one opportunity. If you take this to Google now, you get sent to a sandbox. But I also would like to tell you that it's beginner friendly. But if you have if you can if you've been writing Python, for example, to be much more easier for you. If not, you probably have to start learning from scratch. But this is an opportunity where you can play with different data sets, right? And use the data sets to like you have okay, like let me do it like this. So if you go to this website, they have like a sandbox. Sandbox is just like your own personal workspace, like so workspace, right? And then, like I was saying, if you have prior experience writing Python, SQL, R, all those normal stuff, then it will be easier for you to pick it up. But the point is, with this, you'll be able to get get opportunities to load data sets from European Union constellation, the Sentinel-2. So it's a satellite. You can use some of those data sets across different regions of the world. So if you can even want to do like images across different parts in Nigeria, and then you now you start learning with that. So you pick a particular data set, then you decide what you want to do with it, and then you do it you do everything basically on the sandbox. So that's what makes it very easy and very straightforward. You don't have to load different tools, you don't have to do multiple applications and all of that. You just need the sandbox. You get and you can also do a couple of trainings there. So there are training options there. So in case okay you're doing something and you probably need some insight into how to proceed and all of that. And they also have opportunities where you can ask questions directly to the developers. So if you're stuck somewhere and you need somebody to just put you through into what to do differently or what to do next, you can also ask them directly. So that is an example if what you're looking for is opportunities on like um, training up the like images, satellite images, and using them for different solutions. So they are free data sets, which means for now you probably would not even you don't need any more than the free data set. So you can just start with that. If you have questions, you ask them directly, they would respond to you. Uh, so I guess I hope that has answered your question, Daniel.
All right, thank you very much for that one. I really hope that has answered your question, Daniel. So the floor is still open for more questions. Do you? All right, Daniel said yes. That's wonderful. Thank you very much. So the floor is still being opened for more questions. Do you have any questions in relation to whatever we just spoke about today in relation to satellites? You can unmute your mic and speak, raise up your hand, or chat, type in the chat box. So the offer is still on for any more questions. Me not asking questions is me believing our speaker touched basically every section and we don't have any questions to ask because he has already answered all our questions during his session. So I'm believing there are no more questions. All right. So since nobody's raising their hand and since nobody's typing in the chat box yet, I assume our curiosity has been fed properly this morning. You know, there's just a certain type of people that when they start talking, you just know they know their onions. And Mr. Mustapha is one of them. So once more, can we have a round of applause? A round of applause for our speaker for today's session. Thank you so much for that one, Mr. Mustafa. That was very insightful. I really, 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 really love how you were able to break down this concept for us in ways that was interesting, in ways that was very insightful. And yes, kudos to you for knowing your onions. That's really beautiful. So we've come to the end of today's session. I really hope we are leaving more insightful that we came. I really hope our curiosity has been fed. And I really, really do hope we have now put into, or we are going to put into practice what we basically learned in today's session. And remember, space is not just some abstract tool, but is a tool to be used in sustainable development now, tomorrow, and in the future. So a round of applause for yourselves for staying to this long for this session. So can I see your virtual reactions, please? All right, thank you, Peace. Thank you, Daniel. So right now we'll be going to our announcements for members and basically non-members of Space Club's Lasso. Field trip, field trip, field trip. If you're excited, can I see your virtual reactions? Thank you all very much. So we'll be having our field trip coming up April next month, April 16th. I'll be visiting NIMET and would also be visiting Innovia Labs, right? So all details concerning this particular field trip will be dropped on the general group, right? So you can start paying up, you can start asking your questions, and you do not want to miss an insightful, a very wonderful, and amazing field trip hosted by Space Clubs Lasso. Right, and I would also really urge us to interact or engage with our articles that has been dropped on the General Space Club's Last group. And for every group or for every post that we post on the General Last group, I really admonish us to engage them, like, share, repost, drop your comments, share what you learned, etc. Right? For example, this webinar is going to be posted on the link to basically the webinar on YouTube is going to be posted on LinkedIn. So you can as well like share right when the post is ready and let us know what stood out for you, what you learned today, right? So a round of applause for yourselves once again for being a part of another Space Club's Dasu monthly webinar series. So they're having another monthly webinar series in April and another one coming up in May, and you do not want to miss this. So yes, thank you very much to our speaker once again for making this session very insightful, very engaging and very nice. And thank you to each and every one of us that basically joined this call. So see you next month for another insightful Space Clubs Lasso monthly webinar series. Space Clubs Lasso Ad Astra. Thank you very much and enjoy the rest of your afternoon. Yes, also you can feel free to connect with our speaker on LinkedIn, Mustapha Iderawunmi, right? So in case you probably have any more questions that you'd like to ask, you can feel free to connect with him on LinkedIn. All right, so see you guys on our next monthly webinar series and see you guys during our field trip. Enjoy the rest of your afternoon, guys. Goodbye.